Hello, my dear learners. Welcome to this topic, Infrared Spectroscopy, Fundamentals of Organic Compounds. I, Professor Hemlata Nimje, Assistant Professor, Department of Pharmaceutical Chemistry from JSPM Charak College of Pharmacy and Research, Wagholi, Pune. After completion of this video, learners will able to study the electromagnetic spectrum, differentiate types of molecular vibrations, selection of criteria for IR absorption, vibrational modes for organic compounds, typical IR absorption region, and Hooke's law. Now first, what is electromagnetic spectrum? The entire range over which the electromagnetic radiation exists is known as electromagnetic spectrum. It is started here from X-ray to radio frequency waves. This is the complete entire wavelength ranges where the infrared region exists in between 2.5 micrometer to 15 micrometer. Infrared spectroscopy is also called as vibrational spectroscopy. The wavelength also it can be shown in centimeter inverse, which is from 4000 to 600 centimeter inverse. Infrared spectroscopy further subdivided into near infrared, far infrared and mid infrared spectroscopy. Near infrared spectroscopy has 14,290 to 4,000 centimeter inverse. Mid infrared spectroscopy is 4,000 to 400 centimeter inverse. Far near spectroscopy is from 700 to 200 centimeter inverse. Now shift to the molecular vibrations. After absorption of IR radiation, the molecule get vibrated. The molecule when vibrate, they have a different types of vibrations. First is stretching vibration. Second is bending vibration. Stretching vibration means the change in interatomic distance along the bond axis. Bending vibration means change in the angle between the two bonds. Now, first we will see the stretching vibration. The stretching vibrations has two types, symmetric vibration and asymmetric vibration. Now, what is asymmetric vibration? Asymmetric vibration means a compound which has vibrations in an interatomic distance increases one bond and decreases another bond, like this. Symmetric vibration in that both the bonds are increases their distances from the center or decreases from the center. This is called symmetric stretching. Symmetric means both the atoms from the center, they are changing their distance symmetrically. Means it may be increase or it may be decrease. But in asymmetric, the one bond may increase the bond distance and another is decrease the bond distance. So that they are differentiated in two types. Now, bending vibration. The bending vibration is related to the change in the bond angle. It is further divided into the two types, in-plane vibration and out-plane vibrations. In-plane vibrations further divided into the two types, scissoring and rocking. The scissoring vibration means both the atoms are close to each other like a scissor. Rocking vibrations, these atoms or molecules are going to move in a same directions. So these like this, it will be moving. The atoms are moving in this way. Now, wagging. The wagging vibrations is out-plane vibration. Both the atoms are going far or near at the same time. In case of twisting vibrations, one atom going far, another atom going near. So in this way, the vibration will take place. So these are all about the bending vibrations. Now we have to reflect and think over it. All type of functional group of organic compounds are identified by IR spectroscopy. Pause this video and think over it. If your answer is yes, now why it is, and if your answer is no, then why it is. You have to write your answer in your copy. Once you have done, then you can start this video. Next. Yes, your answer correct. Not all the compounds can absorb the IR radiation. So here I would introduce about which type of the compound will absorb the IR radiation. So criteria for the IR absorption is the frequency of IR radiation should exactly match with the natural vibrational frequency of molecule. A molecule must undergo a net change in the dipole moment. So for this one example of hydrogen chloride, I would like to tell you. This hydrogen chloride is having hydrogen partial positive and chlorine is partial negative charge. Due to this polarity, there is a dipole moment. So this type of a compound can absorb the IR radiation. Another example is ethylene. This ethylene molecule do not have these net changes in the dipole moment. So such molecules are inactive in IR absorption. So it will not show any IR spectrum. Now vibrational mode. A molecule have many degree of freedom as the total degree of freedom of its individual atom. Each atom has 3 degrees of freedom corresponding to the coordinates x, y, z necessary to describe the position relative to other atoms in the molecule. A molecule of n atom there has 3n degree of freedom. For non-linear molecule with the n atom usually has 3n-6 fundamental vibration mode. For linear molecule have 3n-5 fundamental vibration mode. As the IR spectroscopy is not related with the linear molecule, so we are only discuss here non-linear molecule. For this, one very simple example, water which has a 3 atom. So n is equal to 3. If we keep that n is equal to 3, your answer will be 3. So total 3 fundamental vibration mode is shown by water molecule. These vibrations include asymmetric stretching, symmetric stretching and bending vibrations. So in this way, we can calculate the vibration modes with the help of this equation 3n-6 for non-linear molecule. You can understand for a different molecules, methanol and ethanol, this is the another example where n is equal to 6 and n is equal to 9. Now typical IR absorption region. IR absorption region is from 4000 to 600 nanometer. In that it is divided into the T2 region, functional group region and fingerprint region. The functional group region is started from 4000 to 1400 where the different functional groups are exist. Fingerprint region is started from 1400 to 600 centimeter inverse. Now functional group region, in that various functional groups are absorbed in a different region. In the 3400 to 2800 there is a NH, OH and CH groups absorbed where means alcohol, alkane, alkyne compound may exist. The another region 2400 to 200 region where the triple bonded compound generally absorb. For example, alkyne, nitrile, cyanide, like this. Another 1800 to 1600 centimeter inverse wavelength, generally double bonded compound can absorb. For example, alkene, carbonyl compound. Carbonyl compound examples: aldehyde, ketone, esters, amide, like this. These compounds, generally having functional group, they will absorb in this region. So that's why it is called as functional group region. The fingerprint region is started from 1400 to 600 centimeter inverse, where only the bending vibration will take place. Generally, the compounds which has a same functional groups, for example, ethanol, methanol, cannot be differentiated into the functional group region. So in this type of the compound, we will use a fingerprint region so that we can differentiate the compound with the help of fingerprint region, because both the compounds have different bending vibrations. Now Hooke's law. Hooke's law, it is helped to assign the stretching vibration frequencies. It is the relationship between the frequency, force constants and mass, molecular mass. Mu is the atomic mass, which can be calculated by m1 plus m1 m2 divided by m1 plus m2. Now force constant is helped to calculate the frequency. How? If its values is higher, then your frequency values is higher. Then mu means the masses of the atom. If it is lower, then your frequency will be higher. For example, this is the compounds: single bond alkane, double bond alkene, triple bond alkyne. If you see this type of compound, their values goes on increasing. So as the force constant values is increasing, frequency increasing. You can see that their frequency, IR absorption frequency, are increased. So it will be affect. Another is mu, that is molecular masses. If you see CH, CC, O, Cl, Br, there is an increasing in the atomic masses. As there is an increasing in the atomic masses, M, there is a decrease in the frequency, so that it is inversely proportional to the frequency. In this way, with the help of the Hooke law, we can calculate the vibration frequency for any type of compounds. So this all about the theoretical part of IR spectrum. Now in the next video, I would like to tell you about the interpretation of IR's spectroscopy. Thank you very much.